Hey, everybody. Let's see. Where is this? All right, so today we're going to be doing a review of MATLAB. So if you want to follow along with the examples I'm doing in the lecture today, you can go ahead and open it up and have that prepared. I forgot you're in this class too, Simon. I just saw Simon in the previous class. Okay, I need to run to the bathroom real quick, so I'll be right back. All right, I'm back. Oh, I see. Okay, that's good. Okay, it's 5:30, so let's go ahead and get started today. Good evening, everyone. How's everyone doing today?
Good.
Good.
Thanks for asking, Professor.
Yeah, good. Yeah, glad everyone's doing well. Second week, everyone's still happy. It's no midterms, not too much homework yet, so it's a good time in the semester. Okay, and so the plan. Oh, how am I doing? I'm doing well. Yeah, it was my mom's birthday last weekend, and so I visited my parents, and I cooked her a one of her favorite dinners. So that was nice. And by miracle, like she just turned 20 or 65, not 25. That'd be weird. She just turned 65 last weekend, and she already got an appointment for a COVID vaccine too. So she got the vaccine this past Monday, and her second dose is due for next month too. Um, the funny thing is, my dad's a year older than my mom, and like he registered basically first thing when it came available, and he hasn't been able to get an appointment yet for a vaccine. But for some reason, my mom just registered, and then like an hour later, then she had her appointment. So yeah, it's kind of weird, but I'm glad she has the vaccine. Okay. All right, so the plan for today is we're going to be reviewing MATLAB, okay? And so, for a lot of this class, we're going to be using Vascular, which is the research software that I mentioned before. But for a lot of the other stuff, we're going to be using MATLAB. So just because I know, at least from reading a lot of your introduction emails, that there's a lot of kind of anxiety about using MATLAB. So I wanted to make sure I do kind of a pretty comprehensive review with lots of examples just to kind of refresh your memory on how we're going to use it. Okay. Okay. Yes, and so if you're in my 417 class, which occurred yesterday, this is literally exactly the same thing. So if you want to if you want to do something else during this next hour and a half, then you can do that. Or if you want to listen to the exact same thing, then you can do that too. So you can do either one. So so 417 is also a pretty MATLAB heavy course. So I try to design this MATLAB reviews to kind of work for both classes. Yeah. Okay. And so here's kind of the learning objectives that I want to accomplish today. And so we're going to start with basic stuff. So we're going to learn how to define variables within MATLAB. I almost said ANSYS because I just came from a finite element lecture. And then we're going to learn how to set up and solve linear systems in MATLAB. Okay. Then we're going to go over some conditional programming. So if, else, if, and else. Then we're going to learn how to use for loops. And then probably this will be saved till next time. And then finally, we'll learn how to plot stuff in MATLAB. Okay. And so if you want to follow along, you can open up MATLAB. So actually, I have all the code that I wrote for this lecture is going to be here. And I'll post this, and that reminds me, I need to post this for 417 also. I'll post this on the Canvas site so that you can have it with you. Okay, so let's go ahead and get rolling. Okay, all right. So the reason we're learning MATLAB is because this class, along with 417, kind of belongs to the field of engineering, which I call computational engineering. So it's not a formal field yet, but I think one day it might be. And so computational engineering refers to when engineers we use computers and computer softwares to augment and support our work. Okay, and so basically what that means is that when we're faced with something that's really complex or complicated and it's it's too difficult for us to solve by hand, then we can use a computer to basically help us solve it. Okay. And so the key to this is that we need to set up the problem properly for the computer. Okay, because I like to use this phrase that computers are both very, very powerful, but also very, very dumb at the same time. And so in order to basically properly use the computer, you have to kind of speak its language, and you have to put it, you have to put problems in terms that they can understand. And so the way that we do this is that we write computer code. Okay. And so when someone says that they're coding something up or they're writing code, basically they're taking human problems and they're putting it in a form that computers can understand. Okay. And so there's lots of coding languages that are available for engineers to use. And so we're going to be using MATLAB, and the reasons why, we're going to talk about on the next page. But there's also there's also Python, which is, very popular. Probably you've heard of it. C++. C++ is kind of the workhorse of the kind of the engineering world. So C++ has a lot of nice features, and its performance is really good. Okay. There's Fortran. And so Fortran might not be a language you've heard before, because it's basically dead, and it should be dead. But the only reason it's not dead is because there are really stubborn engineers, specifically in this field right here. So specifically engineers that work in computational fluid dynamics. For some reason, they have a weird love affair with Fortran. And so a lot of their codes are written in Fortran. And they're literally the only field of science that still uses it. And so the corpse of Fortran is for some reason being kept alive by CFD engineers. Yeah. No, not Fortran, Fortran. And just to kind of give you a sense of how old Fortran is, the standard the standard for Fortran is called Fortran 77, and the 77 in that names literally means 1977. So Fortran was a language that was developed in 1977, and we're still using the same practices today. And so there was an update in 1990. So there's Fortran 90, and that's used by some people, but Fortran 77 is kind of the default. And actually, if you pick up some modern CFD textbooks, they actually might give you some code in Fortran and expect you to kind of know what to do with it. Yeah. A joke. So my dad actually grew up with Fortran too. And like he likes to joke that this is the language for our family because it's Fortran, which is our last name. And I would always roll my eyes and not speak with him for the next hour whenever he did that. And there's one more language that's really up and coming. It's called Julia. And so Julia, it's you might not have heard of it, but it's kind of trying really, really hard to be trendy. And so if you talk to anyone who programs in Julia, they're kind of they're kind of like the CrossFit people of the programming world. So they not only do they love Julia, but they love to tell people that they use Julia too. So there's kind of a cringe reaction from a lot of the other community because of that. But Julia is actually really nice for a lot of things. So actually, in like 5-10 years, I can see Julia like overtaking MATLAB as the kind of the programming language of choice. But that's neither here nor there. So that's in the future. Yeah. No, they're not. Yeah. Okay. And so that's enough kind of side conversation about programming. I have a lot to say about programming languages. But basically, all of this basically allows us to simulate problems that are governed by differential equations. Yeah. Okay. And so why are we using MATLAB? So MATLAB is a program that's specifically designed for performing mathematical calculations. Okay. And so it's primarily designed for ease of use. Okay. And so what I mean by that is that the programming conventions and all the built-in functions within MATLAB really makes it so that you can open up MATLAB and then kind of just hit the ground running without having to fuss and wrestle with the program all that much. Okay? And so kind of once you get used to it, I think MATLAB is probably one of the most intuitive, because a lot of times you'll be writing a program and you say, oh, I wonder if there's a MATLAB function for this. And 9 times out of 10, there is. And so you can use that. Okay. And so it's used a lot in education. So probably you guys have taken previous classes in MATLAB. But despite probably what you might hear online, it's actually used a lot in research and in professional settings too, because it is so easy to pick up and use. Yeah. And so MATLAB, I think, has a huge audience of people who don't want to be hardcore computer programmers, but then they still want to take advantage of a lot of the advantages of programming, and that's kind of what MATLAB is designed for, right? And so the reason it's maybe not used for the heavy code is that it is pretty slow. And so if you compare to like things like Python or C++, MATLAB is always going to come in last. And so you're never going to see a big code written in MATLAB. Okay? But for kind of the size of the problems that we're going to be considering in this class, MATLAB is great because you're not going to really notice the performance difference because we're going to be working on fairly small problems. Okay. And so anytime you have to do any quick prototyping, MATLAB is kind of your go-to for that. Okay. But the code that's in Vascular, which is our research software, that's actually built on Fortran, kind of funnily enough. So but we aren't actually going to be programming in Fortran. We're just going to be using that code. But any code that we develop in this class will be in MATLAB, and so that's kind of why we kind of emphasize that here. Yeah. And so, question in the chat. So, how about C language? So, C is kind of in the same vein as C++. So, C is also very popular. But I kind of lump those together because they're very kind of similar to each other. I know that they're not exactly the same, but a lot of codes that are written in C++ are also compatible with C as well, and vice versa too. Question: do I use all these languages? So I have used all these languages. The ones I probably use the most often nowadays are probably MATLAB and Python. For all the kind of the heavy duty, like heavy lifting programming, I like to use C++ for that. But just because, I've worked with codes that are in Fortran, I know Fortran too. And Julia, I've gone to some workshops, but I haven't used it for anything too serious yet. Yeah. Okay. And so here's just kind of more reasons why MATLAB is useful. Okay. And so one other reason that MATLAB is nice is that, relatively speaking, the error messaging in MATLAB is more helpful than others, than other languages. Yeah. Once you know one language, then it's not that hard to pick up other ones because they all kind of use the same conventions. It's just kind of small things here and there. Yeah. Oh, one other thing that makes MATLAB nice is that it has a very strong online community and documentation. Okay. And so the nice thing about MATLAB is that it's developed by just one company, basically. So it's developed just by MathWorks. And that actually has a lot of benefits because they're responsible for basically, any kind of documentation. And so, if you want to look up something, say, how do I use this function in MATLAB, you can look up the documentation and it's very standard. So if you've ever seen it before, it's really nice. And there's usually lots of examples. There's a lot of use cases, and the website looks beautiful and everything like that. So that's really, really nice too. Okay. And MATLAB's cheap too. And so that might be funny to say about a program that costs $100 or not if you pirate it or if you download it from the school. But $100 is actually really cheap compared to some other engineering softwares, which can run you up into the thousands of dollars. So relatively speaking, MATLAB is pretty cheap. So if you go and you graduate from here, you ask your manager to buy you MATLAB, they're probably not going to blink twice. They'll probably say, sure, here's $100, go buy yourself MATLAB. Okay. All right, so let's get into actually using MATLAB. So the first step that we're going to learn is how to actually define variables. Okay? And so variables are kind of the starting point for any kind of computer programming. And what variables are basically labeled entries or labeled entities in a computer program used to store information. Okay. And so in MATLAB, there's, we consider basically three different types of variables. So the first type of variable is a scalar. And a scalar is simply just a single number. Okay? It could be an integer, it could be a decimal, it could be even an imaginary number. So all of those are considered scalars. Okay? Next type of variable is a vector. And so a vector is simply just a collection of values organized as a list. Okay. And so, I think everyone kind of is familiar with with what a vector is. Okay. And the last type of variable that we'll consider is a matrix. And so matrix, again, is a collection of values, but instead of being organized as just a single list, now it's listed as kind of a matrix. So it's kind of like a 2D, I call it like a 2D construct. Okay. Okay, so every time you define a variable, there's two things that you need. So you need to give your variable a name, okay, and then you need to give it its value. And then the way that you connect these two is you use this special character here called equals. Okay, and so equals is a very special character of computer programming that means assignment. Okay, and so whenever you have just a single equal, that means you're assigning a value to a variable somehow. Okay, and so here's an example, just very simple. And so Here on the left-hand side of the equal sign, I have the variable name. And so the name of this variable is simply a scalar example. Okay. And then we have the equal sign. And so the equal sign basically means that we're going to assign this value to this variable name. Okay. In this case, we have the value of 6. Okay. And then at the end of the line, we have a semicolon. Okay. And so actually semicolons in MATLAB are optional, so you don't have to put them in there, but they usually make it a little bit nicer because your MATLAB is not going to vomit a bunch of stuff to the output window if you put semicolons. Okay. But for variables, we're going to use this convention a lot. So remember, the equal sign means assignment, and then what that assignment means is that we're assigning a value to a name. Okay. Okay. And so now that we've defined this variable scalar example, we can use this variable in other parts of the code. Okay. And so now in this case, we've assigned a value of 6. And so whenever we use this variable scalar example in other parts of the code, we can just plug in 6 there. Okay. So it's basically kind of intuitively kind of what you come to understand about a variable. Okay. And so let's use this variable in a calculation. So let's define a new variable. And so this new variable will give it the name scalar operation. Okay. Once again, we're going to use the equal sign to denote assignment. And then the value for this new variable is going to be an arithmetic operation that used our previous variable. Okay. And so the formula for that is given by this. So the formula is going to be 3 times scalar example, where scalar example we know from last time is 6 plus scalar example. And so the value of this variable is going to be 3 times 6 plus 6. And so if we perform that arithmetic, we get 24. Right? And so this the value of scalar operation here is going to be 24. Okay. Okay. And so that's how we define scalars and how we use them in calculations. But we can also use variables to refer to vectors as well. Okay. And so the way that you define a vector is like this. Okay. So I know this is not the only way to define vectors, but I usually like to use the square brackets and the commas. Okay. So remember, a vector is nothing more than just an ordered list of values. Okay. And so in this example here, I'm using the same format. And so on the left-hand side here, we have the name of the variable. And so our name here is vector example. And then we're using the equal sign to denote assignment. And on the right, we have our value. But instead of just being a single scalar value, now our value is going to be a vector, which is going to be these three numbers in a list. Okay. So we 7, 1, 4. Okay. And so now from here on out, this vector example here will be referred to this ordered list. Okay. And so, with vectors, we can perform operations just like scalars. And so we can perform a vector-vector addition. Okay. And so if we define this new variable vector operation, we can assign it a value which is equal to this previous one plus another vector. Okay. And so it's going to be 7, 1, 4 plus 4, 1, 7. Okay. And then when you add vectors together, you just add the entries, one after another. Okay. So we add the first entry together. And so the first entry in vector operation is going to be 11. And then the next entry is going to be 1 plus 1, which is 2. And then our third entry is going to be 4 plus 7, which is 11. And so at the end of this operation here, this vector operation is going to be a vector with 3 entries. And it's going to be 11, 2, and then 11. Okay. Any questions so far on defining variables? Okay. Okay. And so there's some special MATLAB functions that you can use to define special vectors as well. And we'll use this quite a bit because they're pretty convenient. Okay. And so the first function that I want to show you is a function called Linspace. Okay. And so Linspace is a way that you can create a vector with a specified starting value and ending value, and you can specify the number of entries or how long the vector is going to be. Okay. And so in this example here, I'm using the Linspace function. Okay. And so, we're creating a new variable here. So we're using the same kind of syntax that we used before. And so we start with the name of the variable on the left-hand side. Then we have our assignment. And then the value of this variable is going to be the output of this function right here. Okay. And so we're going to call this Linspace function here. And so this Linspace function takes 3 parameters. And so this first parameter here is going to be the starting value. And so this tells us that, we want to start our vector at with a value of 0. Okay. The next entry is going to be the final value, and so that's going to be the last value in the vector. And then this last parameter right here, this 5, this is how many entries that we want in our vector. Okay. And so the output of this code is basically shown right here. Okay. And so it's going to give us a vector with 5 different entries. So it has 5 numbers. The first value is going to be 0, which is what we specified. The last value is going to be 10. And then they're going to space out all the interior entries of the vector such that they're all evenly spaced and that the number of entries is 5. Okay. And so if we kind of, follow this out, then, with 3 interior entries, if we space them out by 2.5, then we go 0, 2.5, 5, 7.5, and 10. Okay. And so this vector here kind of satisfies all the parameters here. And so if you want to make like a vector that kind of counts up to a certain place with an even spacing in between each entry, then linspace is your function. So that's kind of how you do it. Okay. Another example, another function that we can use to define vectors is the zeros function. And so this is one that we're going to use quite a lot. And so the zeros function will create you a vector of a specified size, but then all the entries are just going to be 0. Okay. And so as an example here, we have a code segment which is going to produce, a vector that's 100 entries long, and then each of those 100 entries is just going to be 0. Okay. Okay. So any questions on this so far? You guys have seen these functions before, right?
Can you create, like, say, you know how you have the equal spacing and the starting number and ending number?
Mm-hmm.
Those numbers that it creates for 2, 3, and 4, are they random, or do you choose what goes in there?
So those numbers in here, those are chosen such that the spacing in between each entry is even. And so you only have to specify the starting and ending one, and the starting and ending values, and how many entries that you want in the vector. And then everything else it chooses such that all the entries are kind of evenly spaced between each other. Yeah.
Got it. Thank you.
Mm-hmm.
On the zeros example, is that one just specifying the amount of columns?
Exactly,
like
right.
100 by 1 matrix.
Exactly. Yeah. Thanks for asking about that. Yeah. So when you call the zeros function, you basically have to define the dimensions of your matrix. So the first parameter here is the number of rows, and then the second parameter here is the number of columns. And so by calling zeros 100, 1, then I'm creating 100 rows in my vector and then 1 column. Okay. And so if you have a 1 here, that means it's just going to be a vector. So it's just going to be 1 list. But if you want to create like a matrix, then you can put a different value for the number of columns. Yep. Mm-hmm. Okay. Rows, columns. Okay. And so now let's talk about manipulating variables. So once your variable is defined, you can manipulate its value. So once you define a variable, its value isn't stuck forever. So you can change it if you want. Okay. And so to change the value of a vector of a variable, we're once again going to use this equal sign. Okay. And so in this example, I know before we assigned a value of 6 to scalar example, but say that later on we want to change the value to 9. And so if we want to do that, we just have to say scalar example is equal to 9. And so that assigns a new value of 9 into scalar example. So from this point in the code onwards, scalar example is going to have a value of 9. Okay. And so I do want to highlight one thing with this, which is the fact that whenever you change a value of this, the changed value only occurs at this point going forward. Okay. And so if you look at kind of this code that I have here, you can see here I have 2 lines here, which assign the value of scalar example. Okay. And so on the first line, I assign a value of 6. And then on the second line, on line 14, I assign a value of 9. Okay. And so you have to keep in mind that when you run a MATLAB program, it runs it kind of from the top, and it reads it kind of line by line. Okay. And so when you perform this operation right here, the value of scalar example is still 6 at this point because it hasn't reached this point where it's reassigned at 9. Okay. And so if you want to change the value of a variable, you want to use that in a calculation. You want to make sure that you change it in the appropriate spot, because at this point right here, scalar example is still going to be 6, and so you're going to have 3 times 6 plus 6, and so this is still going to be 24. So even though later on you redefine it as 9, that's not going to take effect until, everything after this line right here, okay? And so when you're changing variable values, the ordering is and where you put it is important, okay? Okay. And so we can also use these variables and other mathematical operations to set the value of another variable, okay? And so we look at kind of this quick example right here. So we say, we define a new variable, and we call the new variable 7, right? And then we define a second variable called whodis, and then we can redefine, the value of new variable to include this whodis, okay? And so we say that new variable is equal to whodis plus 5/2 times whodis, okay? And then that redefines it. So in this case, this still ends up being 7 because we have 2 plus 5/2 times 2. And so that equals 7. But this kind of just shows you that you can redefine a variable using mathematical operations. Okay. And another way that you can change a variable's value is to update it. Okay. And so we're going to use this notation a lot in this class too. So this is kind of important to know, where let's say that you want to add something or subtract something from the current value of a variable, okay? And so in this case, let's say that, we want to take whodis, and so let's say whodis is equal to 2, okay? And then to this, we want to add 9, okay? And so we don't want to just completely replace it. So because if we just do whodis is equal to 9, then what that's going to do is it's just going to assign 9 to that variable, okay? But what we want to do instead is we want to add 9 to whatever was there before, okay? And so the way that we can do this in code is to kind of put the name of the variable on both sides of the equal sign, okay? And so you'll see this notation quite a bit where you have, the name of the variable on one side. And so this is kind of the same, our same variable assignment that we did before. So we're saying, we're saying that the whodis variable, and we're assigning it a new value, okay? But then when you see this, the name of the same variable on the right side of the equal sign, what we're doing is we're saying that, take whatever the old value of whodis was, and then to that, we're going to add 9, okay? And so the way to kind of read this line of code as a sentence is to say that the new value of whodis is the old value of whodis plus 9, okay? And so what this will do is it'll take the old value of whodis, which is 2, and so it'll do 2 plus 9, okay? And so we'll use this quite a bit because in in computational engineering, we usually don't like to create too many variables. So if we can kind of reuse a variable and kind of add to it, that kind of saves us some lines of code, and it saves us a lot of memory too. And so when we need to update a variable value and just simply add to it or subtract to it, we're going to use a format like this. Okay. I don't run a meme page, but maybe I should. Okay. So any questions on this?
So from that point forward, it's gonna equal 11, right?
Exactly, right.
Professor,
Yeah.
you wouldn't have to change the who underscore this to like who underscore this 1 equals to who this plus 9.
So
wouldn't
it's,
that be 2 equals 2 plus 9?
right. So the key here is to actually use the exact same variable name before, because we want to kind of add to it and kind of update its value. And so after this, whodis will forget that it was 2, but we've added 9 to it, so then we update its value. So the key here is to kind of use the same variable name. So right here, it kind of looks weird because it's kind of an isolated case. But then once we write more code in the class, and you'll see that there are cases where we simply just want to update the value of a variable, not necessarily create a new one. This is how we would do it. Yeah.
That makes sense. No, thank you.
Mm-hmm. Yeah. Okay. And so now let's talk about how we use variables. So, we've gone, now that we've talked about how we can define them and manipulate its values, let's talk about how we actually use them in computer programs. Okay. And so the first way to use variables is to simply store some important problem parameters. Right? And so let's say that we're writing a computer program to compute the area of a circle. Okay. And so to do this, we need to know the radius of the circle. And so we need to define a variable here called radius, okay? And then we can define its value. And then later on, we can then use this variable in some calculation. So let's say that, we say the area is equal to pi times radius, okay? And so typically, whenever you use a variable like this just to store what I call problem parameters, their values typically don't change after this. And so Once you define this variable as 4, then typically you want to avoid changing the value of this variable because it represents something kind of physical. So you kind of want to maintain that throughout your program. Okay. And so another use for a variable is to kind of temporarily store values that are used in calculations. Okay. And so I call these kind of calculation variables. And so these are variables that typically, their values are changing, a lot. They're regularly being overwritten, updated, and things like that. So these are kind of temporary kind of storage variables that we need that are kind of necessary to run a program. Okay. And so, this will kind of become clear, but, as we kind of write more. So it's kind of something that you kind of need to see kind of in context to kind of really get it. But, when you're using variables, these are kind of two of the main uses that you can use them for. Okay. And so one thing I want to really emphasize here is that when you're writing code and you're defining your variables, it's really important to use very descriptive variable names. Okay. Because, if you wanted to save on typing, one thing that you could do is you can just say that R is equal to 4, right? So we can just change this to R and just change that to R, right? And so this will accomplish exactly the same thing. And so this will compute the area for a circle with a radius of R, okay? The problem with using variable names like this is that say that, you're looking way down here in the code and you see R, right? And MATLAB tells you that there's an error somewhere in this code. If you just have R, R can be almost anything. It could be radius, it could be Raymond, it could be, Raymundo, I don't know why those are the other two words of R that I came up with, but, R could be almost anything, right? And so, when you're writing computer code, and this goes, beyond this class. So if you're, programming for another class, use variable names that are descriptive. And so that, when you go and debug and you look at the code later on, you'll know exactly what that variable is supposed to represent. Okay. And so you want to avoid using things like X and Y because those are not very descriptive, and avoid using variable names that don't make sense within the program. And so I'm guilty of this more than anyone, that when I get really frustrated with my programming, I start to curse and I start to put profanity in my programs. And so I won't dock any points because of this, but try to avoid it too much because it's not helpful for your debugging when you do that. Okay. Okay. Yeah. Okay. And so that's everything with the scalars and vector variables. Okay. And so I want to take some time and talk about matrices. So matrices are are going to be really important because they're going to form the backbone for a lot of what we're going to do. Okay.
Professor,
Yep. What's up?
we gotta define the variables before the equations, right?
Yes. Exactly. Yes.
If not, it's not gonna work, right?
Exactly. So if you have this equation up here like this, then MATLAB's not going to know what to do because you haven't defined radius yet. Because remember, MATLAB reads your program kind of from top to bottom. And so if it's reading your program and it comes to this line and it says, okay, I know what pi is. So pi is something that's built in. It comes to radius and it's like, I have no idea what radius is. And so it's going to throw you an error. So you need to have it kind of after this. So you need to define your variables first before you use them. Yeah, good point. Mm-hmm.
Thank you.
Okay, and so let's talk about matrices. So matrices are very important data structures because they kind of form the basis for linear algebra. Okay, and so the reason we like to use linear algebra in computer engineering is that computers are really good at doing linear algebra. And so what I mean by that is that they're really good at solving systems of linear equations. Okay, and so the aim for a lot of computer engineering techniques is to take a very complex real world problem and then put it in terms of a linear algebra problem. Because if you can do that, then the computer can solve it for you. And so it's actually fascinating. So like things like things that you might not seem to be that you might not think are connected, like maybe like blood flow simulations, which is what we're going to do here, and you compare that to machine learning. Actually, both of those techniques aim to take their problem and turn it into a giant, linear system of equations, because the matrix is just really good at that. And so, all different kinds of computational techniques, you can kind of boil it down to say, how can we take this really complicated thing and turn it into a linear system of equations so the computer can solve it. Okay? And then in order to basically work with linear systems, we need to define matrices. Okay? And so let me go over kind of the first way to define a matrix, which is, I think, probably the way that a lot of people learn first, which is what I call manual assignment. Okay. And so let's look at this line of code right here. Okay. And so in this line of code, I'm going to define this matrix kind of row by row. Okay. And so I'm going to start with the first row. And so the first row is going to be 1, 1, 1. Okay. And so you'll notice that, because all of these entries are in the same row, I use commas to separate them. Okay. So when you're defining matrices in MATLAB, comma means, same row. But then when you're ready to go on to the next row, then you use a semicolon for that. Okay. And so the semicolon tells the matrix that, okay, I'm done with the first row. Now I'm ready to start assigning the second row. Okay. And so our second row here is just going to be 9, 9, 9. Okay. And so that's the second row in the matrix. Once again, they're separated by commas. And then to go to the next row, we again use a semicolon. And then our last row is just going to be 4, 6, 8. Okay. And so here we have a 3 by 3 matrix, which you can kind of see right here. Okay. And so that's one way to define a matrix. And so that works well if you kind of know all the matrix values kind of ahead of time. But it turns out, when you're doing a lot of the methods that we're going to discuss in this class, a lot of times you don't know what all the values you're going to put into the matrix kind of beforehand. Okay. And so another way to define a matrix is to kind of create what's called an empty matrix and then fill in the values later on. Okay. And so here's kind of an example of that. Okay. And so you can see in line 42 here, then I've created a matrix, which is empty. Okay. So you can see I've used this zeros command again. And this time I've specified it to be a 3 by 3 matrix. Okay. And so now MATLAB will create a 3 by 3 matrix, and all 9 entries in that matrix will be 0. Okay. And then later on, what we can do is we can assign values to that matrix. Okay. And so you can see here that I'm assigning the value in the first row and the first column to be 1. Then I'm assigning the value in the first row and the second column to be 1. Then in the first row and the third column to be 1 as well. Okay, so I basically kind of recreated this line right here with these guys. Okay, and then you can continue on with all the other values, right? And so if you compare these two things, so the result of these two segments of code are the same. And so you might be asking yourself, why would we ever do the second part where it's just a lot more typing? Or if you're lazy, a lot of Control C, Control V, right? A lot of copy and paste. Right? And so the reason for that is what tends to happen with a lot of these computational problems is that you create a matrix, and actually the vast majority of the entries are going to be 0. Okay, and so let's say that we create a matrix that's going to be 100 by 100. Maybe 99% of those entries are going to be 0. And so it actually ends up saving you a lot of typing, because then you don't have to go 0, 0, 0, 0, 0, right? And here, with this method, we only worry about the non-zero entries of the matrix. Okay, and then that's actually going to save us a lot of work. Okay. Okay. Any questions on this? Check the chat. Okay. Okay. And so that's 2 ways to define matrices. Okay, and this is just me, but when I see matrices being defined like this, I personally find it a little bit easier to read than something like this, which things can get jumbled up on one line quite a bit. Okay. Okay, and so once you define your matrix, you can manipulate its entries. Okay, and so we can use the exact same update notation that we did before to add a value to that entry. And so let's take this first entry here. And so let's say that for this example, we want to add 47 to whatever was in this entry here. Okay. And so to do that, we're going to use the same update notation. So we're going to have the variable name. Okay. And in this case, since we're just doing one value in the matrix, we have to specify its coordinates. And so we're going to say the variable at location 1, 1 in this matrix is equal to the variable at 1, 1 plus 47. Okay. And so what this says is that take, whatever was there before. So take the old value at this entry in the matrix, and then add 47 to that. Then that's going to be the new value in there. Okay. And so now this is going to change the value of this entry in the matrix here to be 48 instead of 1. Okay. And so this is, you can apply basically the same thing, because basically once you apply this 1, 1 here, then this becomes a scalar variable essentially. And so you can do all the scalar stuff that you've done before. Okay. Okay. And so let's talk about solving a linear system of equations. Okay. And so this is probably one of the most powerful things you can do in MATLAB is you can take a system of equations and solve them, really easily. Okay. And so in this example here, I have 3 equations and 3 unknowns. Okay. And so our 3 equations are given by 3x1 plus 5x2 plus 7x3 is equal to 0. And then the next equation would be x1 plus 9x3, and that's going to be equal to 3. And then our last equation is x2 minus 3x1 is equal to 6. Okay. And so in order to actually solve this as a linear system, what you're going to do is you're going to extract the coefficients from each of these terms. Okay. And so, for the first equation, you can see that we just pulled out 3, 5, and 7. And so for the next equation, we have 1 for the first coefficient. And since x2 doesn't show up in this equation, we're just going to have a 0 for that part. And then a 9 for the coefficient of x3. Okay. And then for the last row, we're going to pull off the equations here. So since we have a -3 in front of x1, that's what we're going to put there, a 1 for x2, and x3 doesn't show up, and so we just put a 0 on that side. Okay. And then the right-hand sides of the equation, you just pop them into this vector. Okay. And so once you have the system of equations in this form, you can see here that we have a matrix, which I like to call the left-hand side matrix, or LHS. And then we have a right-hand side vector here, or RHS. Okay. And so if we define those in MATLAB, and so you can see I've used kind of the manual notation here to define those. If we want to solve for the solution here, we can just simply use this magical backslash notation. Okay. And so kind of if you want to see it more clearly, it's here. Okay. And so once you define the matrix and once you define the right-hand side vector, the way that you can solve it is you take the name of the matrix variable. And so in this case, it's LHS matrix. Then you use backslash, okay? And so this is different than /. So / is what you use for division, okay? Backslash is what you use in MATLAB when you want to solve a linear system, okay? Then you do backslash, and then you do the vector, okay? And then this will solve your system for you, okay? And so if we actually run this code, we can actually view it. And so we can see our solution is going to be an X solution. And so if we go into the problem workspace, we can see that this is the solution to this linear system of equations. So we have minus 1.8774 for x1, x2 is 0.3677, and x3 is 0.5419. Okay. Any questions on this? Okay. Okay. And so that's kind of everything with variables and question. Let me see. Yep. So that's everything with variables and solving linear systems. So now let's go into some little more advanced stuff. So let's start with if statements. Okay. And so if statements are a way that you can basically tell your program to do something different depending on the situation. Okay. Because sometimes, you're writing your code and you say, depending on what the conditions are, you want your code to do one thing or another thing. And so the way that you do that in code is with an if statement. Okay. And so here's kind of the general anatomy or the general structure of an if statement. Okay. And so it starts out with if. Okay. And when you type if in MATLAB, then it turns blue. And so that tells you that it's a keyword. Okay. Then you do some parentheses. So the parentheses are, I know you don't have to do them, but I like to use parentheses for my if statements because to me, it makes it a little bit easier to read, okay? And then inside these parentheses, you need to have what I call like a check condition, okay? And so this check condition is something that can either be true or false. And so in programming terms, we call this a Boolean expression, okay? And so if you look at this example here, then my Boolean expression is to see, if this variable needs correction is less than 5. Okay. And so this is something that can either return true or false. And so in this case, we have 9, and so we plug in 9 right here. And so we check if 9 is less than 5. And so in that case, it's false. Okay. But the key thing for this check condition here is it needs to be a line of code that can either be true or false. Okay. And so what the if statement is going to do is it's going to check the check condition. And then if it returns true, then you're going to execute the code inside the body of the if statement. Okay. And so in this kind of general statement here, then I have, perform work if true. Okay. But, if this check condition is false, then what it's going to do is it's going to ignore everything in the body of the if statement. Okay. And so in this example here on the right, it actually is going to return false. And so we're not going to reassign this value here. We're just going to kind of move on from there. Okay. Okay. And so here's 2 examples. So, I've shown you a case where it's false and we're not going to enter the body of the loop. But, if we change this value to 3 right here, then we check to see if 3 is less than 5. And then that's true. Okay. And so since that's true, we're going to enter the body of the loop and then execute all of the code that's on the interior right there. Okay. Question. So do if, else if, and else statements need to be written in Boolean logic? Typically, yes. And so I usually write them with Boolean logic because that's kind of what makes the most sense. But there's some fancy things I think that you can do that's not Boolean logic, and so this is getting a little bit advanced, but you don't have to know this. But Boolean logic is nothing more than just 0 and 1, and so actually what when you run a check condition, if it's true, I believe it returns a 1. But if it's false, it actually returns a 0. So actually, you can put if 1 right here, and then that will actually do the same thing because that's what it is, right? And actually, any value that's not 0 is actually the same as 1. So you can do if 5 right here, right? Or if 6 in this case, because my finger slipped. And then that is actually also valid too, because that's actually something the computer can understand. Because it just interprets it as 0s and 1s. But for ease of understanding, then Boolean logic is kind of the easiest thing to do. But if you take kind of an advanced computer science course, you can do some really fancy stuff with that stuff. But we're not going to get into that here. But so for this class, just kind of stick to Boolean logic.
Wait, so since 3 is less than 5, does that mean that the needs correction is now 5?
Yes, yeah. And so it's in this case, since 3 is less than 5, we're going to enter the body of this if statement. And so now it's going to reassign the value of needs correction to be 5. Yeah. And so after this if statement, I'm going to write a comment.
And if it were to be greater, it just ignores the code, right?
Exactly, right.
Okay.
Mm-hmm. But yeah, if it was 9 in this case, then if it's 9, then it ignores everything there. Then after this if statement, then needs correction will still be 9 in this case. Yeah. Mm-hmm. Okay. So that's if statements. Okay. So that's kind of the most basic way that you can incorporate conditional programming. And so now let's talk about else if. Okay. And so else if kind of adds another layer of complexity onto our if statements. Because sometimes there's more than one condition that we want to check. Okay, and in particular, if the first statement fails, then we want to have maybe we want to check something else, in case we want to do that. Okay, and so the anatomy of an else if statement is kind of like this. Okay, and so in order to have an else if, you need to start with an if. Okay, and so the first thing you write is if, and the same thing as before. You have to include a condition right here. And so, this is a condition that can be true or false. Okay. And then after that, you have your body of the code here, and then you have your second condition right here, which is condition 2. Okay. And then you start that line with else if, right? And then the way to kind of read this, this code segment here is that the first thing that the program is going to do is it's going to check if condition 1 is true. Okay. And so if condition 1 is true, then what it's going to do is it's going to execute the body of just that if statement and nothing else in there, okay? And so if condition 1 is true, then we're going to do this work, and then we're going to ignore everything else, okay? So we're not going to do that work. We're just going to do this work, okay? But, you know, if for the case where condition 1 is false, okay? If condition 1 is false, then what the program is going to do is it's going to check condition 2, okay? Then if condition 2 is true, then we're going to do that work, okay? So we're going to do the body of the Elsif, okay? And so, you know, that's our second case. If condition 1 is false, but condition 2 is true, then we just do the body of the Elsif, okay? But if both condition 1 and condition 2 is false, you know, then we kind of ignore everything, okay? And so I think that the part where I think people get confused is what happens if both condition 1 and condition 2 are true, okay? So what if both of them are true? And so I think generally what people will say is that, you know, we should execute both of these codes. But, you know, that's actually not going to be, that's actually not going to happen because, you know, once condition 1 is satisfied, then, you know, we do this work and the program's not even going to check condition 2 because condition 1 is already satisfied, okay? And so when you use if, else, if, it's either one or the other. So it's never both, okay? And so that's kind of the important thing to know about these guys, okay? Okay, and so let's look at some examples. So let's look at an example where you know, the else if is satisfied, okay? And so we have you know, this variable called needs correction, and it has a value of 11, okay? So first thing we're going to do is we're going to check the condition on the if statement, okay? And so first we check, so if needs correction is less than 1, okay? And so we say, is 11 less than 1? And so in this case, that's false. And so, you know, we're not going to execute this. And so now we check the condition on the else if statement, okay? And so now we're going to check and see if 11 is greater than 7, okay? And so since this is true, what we're going to do is we're going to execute the code within here, okay? And so at the end of this if statement here, needs correction will be 7 because condition 1 of the if statement was false, but then condition 2 was true. And so we enter, you know, the body of the else if statement, and then we do that one, okay? Okay. Now let's do a case where the first condition is true, okay? Now we have the kind of the same if statement here, but now our needs correction starts with a value of 0, okay? And so in this case, you know, we check the first condition. So we check if needs correction is less than 1. And so since that returns true, then we're going to, you know, enter the body of this if statement. And so in this case, we're going to reassign the value of needs correction to 1, okay? And so at the conclusion of this if statement, needs correction will be 1, okay? And so remember, whenever the first if statement is satisfied, it doesn't even check, it doesn't even read this part of the code right here. It just says, you know, you're worthless to me now, okay? Okay, and so let's do a case where, you know, neither case is true, okay? And so let's say we have this case right here where needs correction is equal to 3, okay? First, we check if needs correction is less than 1. And so that's obviously false. And so we check if 3 is less than 1, so that's not true, okay? Then we check to see if needs correction is greater than 7. And so that's false. And so because 3 is not greater than 7. And so, you know, we enter none of these. And so since none of these codes executed, needs correction stays, its value kind of stays the same. And so after this if statement, needs correction will have a value of 3, okay? And so in this case, nothing changed because neither condition on the if statement was satisfied, okay? Okay, any questions on this?
I have a question, Professor. For
Sure.
the middle example on the notes,
Mm-hmm.
so since 0 was less than 1, you're gonna bring that one to the else if, or I'm kind of confused on to like what you mean by like
Right. So since
when it's true, right?
yeah. So when this first one is true, then we're going to execute every code that's between the if and the else if. So in this case, we only have one line of code here, and so you know, if this is 0 right here, right, then this first condition is true, right? And so when this first condition is true, then we're going to execute all the code in between this if and else if right here, and we're going to do nothing else, okay? And so we're going to execute this code and then kind of ignore everything else. So if this was true, if this first condition was true right here, and this first condition was satisfied, then at the conclusion of this if statement, then needs correction will have a value of 1. Okay, because we entered this if statement and we executed this code, and we ignored everything else because our first condition here was true.
Oh, okay, that makes more sense. Thank you.
All right, any other questions on Elsifs? Okay, and so the last kind of sibling to the else if loop is the else statement. Okay, and so the else statement is a way to kind of be kind of like a catch-all. And so else basically says if all else fails, and so if all the other conditions fail, then perform this code. Okay, and so the general anatomy of an if else statement looks like this. Okay, and so we start out with an if statement, and so we start with if condition 1, and so we check our first condition here, and once again we check to see if this is true, and if this is true, then we just do the statements here, and so we just, in this case, we do this work, and then we ignore everything else. Okay. But if the first condition here returns false, then what we're going to do is we're going to check condition 2. Okay, and so when we check condition 2, we check to see if that's true or false, and if condition 2 is true, then we execute the code that's in the body of this one, so in between the else if and the else, which in this case is called do that work. Okay, but if both condition 1 and condition 2 are false, then we enter the else part of the if statement. Okay, and in this case, we're going to execute everything that's in between else and end. Okay, which in this case is do work, I guess. Right? And so to kind of read this from top to bottom. So first, if condition 1 is true, then do this work. But if condition 1 is false, then we check condition 2. If condition 2 is true, then we do that work. Okay. But if condition 2 is false, then we do work, I guess. All right. And so that's kind of the logic. So remember, for if statements, you check kind of one condition at a time. But if all of them return false, then you do whatever's in the else statement. Okay. And so let's look at this example here. So here we have the same kind of format, and so we use first we check to see if needs correction is less than 1, and so in this case, since needs correction is 3, that's not going to be true, and so we're going to ignore this. Okay. Then we check to see if needs correction is greater than 7, and so we check, in this case, we check to see if 3 is greater than 7, and so since that is false, then we ignore this, and so from there we enter our else statement, which is our failsafe. And so since all these other conditions return false, then we enter here, and so then we assign a value of 4 to needs correction. Okay, and so after this if statement, then needs correction will have a value of 4. Okay. And so the point of an else statement here is that, because whenever you enter an if statement, if you look at kind of these first 2 examples, there's no guarantee that we would do anything in that if statement, right? Because if everything returns false, then we just do nothing. Okay. And so with an else statement, it kind of guarantees that your code does something with this, with this statement. Okay. And so, and sometimes, that's what you want. And so sometimes, you want to, make sure that you do something. Okay. But sometimes you don't. Sometimes, if you don't want to do anything, if all these are false, then you can just leave this out. Okay. And so, this else if and this else, these guys are optional for an if statement. So kind of the bare bones is just this if right here. But then if you want to add more customization, you want to add more use cases, you can use else if and else. Okay. Okay, so any questions on this? Okay. All right, so let's talk about for loops. Okay, and so for loops are a programming construct. They're present in basically all programming languages. So same as if statements, and so for loops allow you to repeat programming statements as many times as you want. Okay. And so the benefit of for loops is that it lets you kind of execute the same code over and over and over again. Okay, and this kind of saves you a bunch of copy. Not only does it save you a bunch of copy and pasting, where say you want to repeat a code 100 times, but it also lets us use what's called this loop index variable. Okay, and this is really important because this is kind of the one of the nicest things about using a for loop. Okay? And so the anatomy of a for loop kind of looks like this. So we start with for, FOR. Okay. And you can see it's highlighted in blue, so that tells you it's a special character, okay, or a special word. Then we define the name for the loop index variable, okay. And so what this loop index variable is going to do is that it's going to count up. So it's going to start at a starting value and count up from there, up until it reaches its last value right here, okay. And so the way that you you code this up is that you start with the starting value and then you put a colon, and then you put the last value, okay? And so in this particular example, I have a starting value of 1, okay? And then it's going to end at 5, right? And so what this loop is going to do is it's going to loop 5 times, and in each iteration, index is going to count up by 1, okay? And then from there, you can enter the body of the loop, okay? And so, whatever you put here is going to be executed over and over. But what I have shown you on the right here is an example of how you can use the loop index in kind of a creative way, okay? And so, one application that you'll see quite a bit is that you'll see a loop is designed to visit every single entry in a vector, okay? And so if you look at line 97 here, you can see that we defined a vector. It's a zeros vector, so every entry is going to be 0, and it's going to be 1 by 5. And so it's going to have 1 row and 5 columns, okay? And so, all of these are going to start out as 0. But let's say that we want to write this code such that each of the entries in this matrix contain all the even numbers. Okay? And so the first entry is going to be 2. The second entry is going to be 4. The third entry is going to be 6. The fourth entry is going to be 8, and then 10. Okay. And so one way that you can do this with a for loop, and so I know you can do this with the Linspace function, but one way that you can do this with a for loop is to do something like this. Okay? And so you write your for loop. So you do for index is equal to, it goes from 1 to 5. Okay. And then, this syntax right here says that, we're going to take this vector and we're going to access the indexed variable or index entry of that vector. Okay. Because remember, index is going to count up. And so on the first iteration of this loop, index is going to start at a starting value, which is 1. Okay. And so when you plug 1 into the code here, you're going to say loop vector at 1. And so that grabs our first entry in the vector. Okay. And we have our equal sign here. So we're going to do an assignment. Okay. And so we're going to assign a value of 2 times index. And so we're going to say loop index is basically loop vector at index, or the first entry in loop vector is going to be 2 times that index. Okay. And so at the conclusion of the first iteration of the loop, loop vector is going to have the entries 2, 0, 0, 0. Okay. Because all we've done is just kind of specify the first entry in that vector, and we need to continue our loop to assign the other ones. Okay. Okay. So that's the first iterations. And so now let's go to the second iteration. And so by the time you get to the second iteration, index is going to update its value, and it's going to go from its starting value up to its second value, which is going to be 2. Okay. And so now that index is 2, we can see that we're assigning the second value in this vector. Okay? So we're going to do loop vector at 2 is equal to 2 times 2, which is 4. Okay. And you can see the output for that here on the left-hand side. Okay. And so after the second iteration of the loop, then our loop vector is going to be 2, 4, 0, 0. Okay. And then we can continue on, because each time that the loop iterates, or each time that it repeats, index's value is going to go up by 1. Okay. And so on the third iteration, loop index is 3. On the fourth iteration, index is 4. And then on the fifth iteration, loop index is going to reach its final value, which is 5 right here, which we've defined. Okay. And then after this iteration, it's going to stop, and then it's going to exit that for loop. Okay. Okay. So any questions on for loops? Okay.
So I have one question. So the
Sure.
index will assign the values 1 through 5 on the zeros vector.
Yes, exactly. Yeah, because remember the for loop, the for loop is designed to kind of repeat all the code that's on the interior here. So this code right here is going to repeat 5 different times. But on each iteration or each time it repeats, the value of index is going to update. And so on the first, and that's kind of how the program keeps track of, how many times that we've repeated this loop. So it basically counts. And so it'll basically say like 1 iteration, 2 iteration, 3 iteration, 4. Okay. And so that counting variable is given by this index right here. And so we can take advantage of that because a lot of times when we do a loop, we want to keep track of, what iteration that we're on. And so we can use that to like assign values in a vector. Which is kind of most common. And what you'll see next is how we can use that to assign values in a matrix as well. Yeah.
Okay, thank you.
Mm-hmm. Okay, and so now let's go to nested for loops. Okay, and so this is kind of the result of Exhibit going back in time to whoever created programming. So he basically said, I heard you like loops, and so now he put loops inside your loops. Okay, and so a loop inside a loop is called a nested for loop. Okay. And so you can actually, I have an example here with two for loops, but you can actually continue this on more and more and more. So you can, Exhibit can keep visiting your code and, putting more for loops inside your for loops. Dog. Okay. And so, the way to kind of read this is, is to say that, is to have what I call like an outer loop and an inner loop. Okay. And I give it those terminologies for, for very specific reasons. So the inner loop, you can think of it as, something that's going to iterate a lot. Okay. And that's kind of why I call it the inner loop. Okay. And so the way to kind of read this is that, you start with the outer loop. And so the outer loop is going to iterate, its specified number of times. And so in this example here, the outer loop is going to repeat 3 different times because we go from 1 to 3. Okay. And then the body of this outer loop is going to execute, 3 times. And then inside this inside this outer loop, we have, our inner loop here. And you can see in this case, the inner loop is going to iterate 5 different times. Okay. And so the way to kind of read this is that, the outer loop is going to be on its first iteration. And then on the first iteration, the inner loop is going to repeat 5 different times. And then after that, you're going to come back to the outer loop. And then you're going to be on the second iteration of the outer loop. And on the second iteration, the inner loop is again going to iterate 5 different times. And then you come back again for the last iteration, and then the inner loop iterates, another 5 times. And so the total amount of loop iterations, you can kind of think of it like this. So you can kind of multiply the number of iterations for the outer loop multiplied by the number of iterations of the inner loop. And so in this case, the total number of times that these lines of codes get executed is going to be 3 times 5, which is 15. Okay. Okay. And so the analogy that I like to think about when I think of nested for loops is a clock. Okay. And so if you think of the hour hand on a clock and the minute hand on a clock, basically, in order for the hour hand to move kind of one position, the minute hand has to make a full rotation. Okay. And so it's the same thing for a nested for loop. So in order for the outer loop to kind of move on to its next iteration, the inner loop has to make a full rotation. It has to kind of complete its full cycle. Okay. And so, basically this whole thing will conclude once the outer loop is kind of done iterating. Okay. But the inner loop, kind of think of it as like a minute and the hour hand. Okay. Okay. And so the most common application for a nested for loop is to assign values in a matrix. Okay. And because the nested for loop structure is nice because we can use basically one loop to loop over all the rows and then another loop to loop over all the columns. Okay? And so in this example here, I have a matrix which starts out empty. So it's going to be a 3x5 matrix. So it has 3 rows and 5 columns. And let's say that we want to assign a value to every single entry in that matrix. Okay? And we want to do it in a way such that all the entries kind of count up by 1. Okay. And so the way that we code this up is that we have a for loop for the row. Okay. And so since the rows here, we only have 3 rows, we're going to have an outer loop that goes from 1 to 3. And then we're going to have an inner loop that goes from 1 to 5. Okay. So that corresponds to the number of columns. And then inside the inner loop, we can start to assign values. Okay. And so, if you look at this line right here, we say that, nested matrix, which is the matrix variable that we want to modify. If we go to the row specified by row index, and then the column specified by column index, that's the entry that we want to specify, and then we can assign a value of count, okay, to that entry. Okay. And so count here is a what I call like a counter variable, and so it's a variable that you're kind of keeping outside of the loop that's going to update. Okay, because you can see each time that the inner loop iterates, we're going to update the value of count by 1. Okay, so you can see here we're using the update notation again, and so we say that count is equal to count plus 1. Okay, and so what this loop will do is that it kind of fills in your matrix kind of row by row. Okay, and so it's going to start with the first row because we're going to start with row index 1, and then it's going to visit every single column on that first row according to this inner loop right here for the column index. Okay, and then it's going to assign values kind of one by one from there. Okay, and so the result of this loop basically looks like this. Okay, so our first row goes from 1, 2, 3, 4, 5, and then once the inner loop is done iterating, then we move on to the next row. Okay, then on the next row we start at 6, 7, 8, 9, 10, and then for the last row, then we go 11, 12, 13, 14, 15. Okay, and so I wrote this example to kind of show you how the loop kind of progresses through the matrix. And so it starts in the upper left, then it progresses in the row because we're looping over the rows first, or we're looping over the rows as the outer loop, and then it moves across the row with the inner loop right here with the column index. Okay. Any questions on nested for loops? All right, so I think the last thing that we'll do today, and I have a couple more examples that we'll do next time, is an example of how we can put an if statement inside of a for loop. Okay, and so this is kind of a combination of kind of the last two ideas that we talked about. Okay, and so it's pretty common to put an if statement inside the for loop, and this is really nice because what this will allow us to do is it allow us the program to basically do different things at different iterations of the for loop. And so if we look at this example here, this example is going to iterate 20 different times, okay? And then this if statement will allow us to do basically something different for each iteration of that for loop, okay? All right. And so on this if statement, remember the anatomy of the if statement is we have to have something or a statement that's going to return true or false, okay? And so the statement that's going to return true or false is I'm going to check the remainder, okay? And so if you've never seen this function in MATLAB before, it's called a modulus or modulo, okay? And so the shorthand for that is mod, okay? And then the parameters for this function is that you give it a number. And so in this case, we're going to give it the index of the loop, okay? We'll remember the index is going to update, every loop iteration. And then we're going to divide that index by 2, okay? And so that's the second parameter that you put into the mod function, okay? And so what the mod function does is that it doesn't actually perform the division. What it does is that it checks for the remainder after the division, okay? And so if you do mod vector index 2, what it's going to do is that it's going to divide vector index by 2 and then return whatever the remainder is, okay? And so let's say that, vector index, let's say that we're on the third iteration, is going to be 3, okay? And so mod 3 comma 2 is going to be 3 divided by 2, which is going to be 1. And then the remainder for that is going to be 1. Okay, and so the mod for this is going to be 1. Okay. Another example, let's say that vector index is going to be 11. Okay, and so we do 11 divided by 2, and so 11 divided by 2 is 5. But then the remainder for that is going to be 1. So we have 5 remainder 1, and so mod is going to return 1. Okay, and then what we're going to do is we're going to check and see if that remainder is equal to 0. Okay. So you can see here I'm using a double equal sign. And so what the double equal sign does is that it's a Boolean expression that checks to see if two values are equal, okay? And so this is actually very, very different from the single equals, because remember the single equals, what we use that for so far is assignment, right? And so for single equals, we're assigning a value to a variable name. When we use double equals, we're checking to see if two things are equal. And so the way to read this condition is say that if the remainder of index divided by 2 is equal to 0, okay? And so what that means is that, we have an even number, because whenever you have an even number and you divide by 2, and then you're going to have a remainder 0, then, we're going to modify that entry in the vector, okay? And so in cases where we have an even index, we're going to assign that entry to have that index value. Okay. And so you can see some of the output here. So it's 20 entries long, so I couldn't fit it, but you can see the first 13 here. Okay. And so you can see for all the odd number entries, so 1, 3, 5, 7, 9, and 11, and a little bit of 13. So you can see all of those are 0 because, you know, the if statement for those return false. But for all the even entries, 2, 4, 6, 8, 10, and 12, you know, the remainder for those is going to be 0. And so we assign that value to the vector. Okay. And so this is kind of just a simple example of how you can combine an if statement with the for loop so that your for loop kind of does something different on every iteration. Okay. Any questions on this? Okay. So if there's no more questions, it's 6:45. So I think, you know, it's safe to call it for today. Okay. And so when we pick this up on Thursday, we're going to do, I'm going to do 2 more examples. And so these are a little bit more complex. So just to kind of give you some more examples of, you know, how you can use these things in combination. Because the most difficult thing with programming is not really, you know, the syntax, it's actually using it in practice. So, you know, my kind of thinking is that kind of the more examples that I give you with this, kind of the more practice that you kind of get with it and the more confidence that you gain with programming. Okay. And so we're going to start with that. And then I'll show you just quickly how to plot stuff. And then from there, we're going to start getting into the fluid mechanics. And so this is kind of the review of MATLAB. And so then Thursday, we're also going to start our review of fluids. Okay. All right. So that's the plan for Thursday. So, so thank you guys for tuning in today. You know, I'll stick around if there's any more questions, but, you know, if not, have a good evening and I'll see you guys on Thursday. Thanks, guys.
Professor?
Yep.
Will you be sharing that MATLAB code you had there?
Yes. Yeah. Let me upload it right now, actually, and I need to do that for my other class too.
Awesome.
Professor,
Yep. What's up?
do you think you could help me? I'm in your Fortran class, and I was following along with your lecture until about halfway through. The program gave me like a bunch of errors, and
Okay.
I couldn't like continue. So yeah, I'm gonna need some help.
Okay. Yeah. It's let me stop recording.